You welcome our dear learners and viewers. This is Robert once again with a lesson in Primary 5 about showing the prime factors on a Venn diagram. I remember in the last session I talked about what we are calling prime factorization, and I said in simple terms that prime factorization just means dividing a certain given number completely using the possible prime numbers, okay? So referring to that, we're just going to use the same method, but of course in this session, we're just going to prime factorize numbers, then we show the prime factors on the Venn diagram. However, we shall still use our prime numbers. These are very important. Our prime numbers, once again, we can remind ourselves of the prime numbers. The prime numbers. I'm just going to give some of them. For example, I'm having 2, 3, 5, 7, 11, 13, 17, and very many others. So these are the prime numbers that are very important as we are prime factorizing numbers. We said in the previous session that prime factorization just means dividing the given numbers exactly or completely using the possible prime numbers. And these are some of the prime numbers we're using. So my intention or my concern in this session is to show the prime factors on a Venn diagram. For example, we can have some examples here. We can have some examples. Like the first question here says, show the prime factors, of 18 and 12 on a Venn diagram. This is the first question we are having. They are telling us to show the prime factors of 18 and 12 on a Venn diagram. Now, before we go to drawing what we are calling the Venn diagram, in the first place we need to prime factorize these two numbers given, right? So we shall first of all come and prime factorize 18. Remember in the previous session we prime factorized the numbers using either the ladder or the factor tree. I'm going to use the ladder method. To prime factorize my 18, I'm just going to draw up this column. Draw up my column. Then I set a provision for where I'm going to put the numbers to use in dividing 18. So in the first place, I'm writing the number 18, right? Then from 18, this is the 18 we are prime factorizing. We are asking ourselves from the set of the prime numbers, which smallest prime number can divide 18? So since 18 is an even number, the prime number to divide it, the first one, the smaller one, is 2. So we shall write our 2 here. Okay? Then we shall ask ourselves, how many 2's can I get from 18? When you divide 18 by 2, what happens? Each one takes a 9, right? That one has brought us to the second step. And in the second step, I'm having the answer as 9. Going back to the set of the prime numbers, which prime number can divide 9 without a remainder? 2 cannot divide it. What can divide 9 without a remainder is 3. So I'm going to write 3 here, okay? So we shall have this one and say 9 divided by 3. What happens? Each one takes a 3, right? Then this one gives us the third step. Then on the third step, the answer I'm having is 3. Which number can divide 3 without a remainder? So it is only 3 which can divide 3 without a remainder. 3 divided by 3, the last answer is 1. When you reach the last step where you see the last answer as 1, it means you've completely prime factorized 18. So what am I going to do? I'm just going to say 18 is equivalent to, I'm now going to write the prime factors, the numbers I've used to divide 18. So when I look at the numbers I've used to divide 18, the first one is 2. So 2 is coming for the first time. I'm writing them in subscript form. Then the next number I used is 3. 3 is coming for the first time. So this is 3 to subscript 1. Then 3 is also appearing for the second time. So I'm going to say this is 3 to subscript 2, right? Then since these are two numbers, I will go to the other part. Then I will prime factorize the next number given, which is 12. So just draw up a column in the ladder and put number 12. So the next number is 12. I write it here. Then I will go back to my prime numbers and I ask myself, which prime number can I use to divide 12 without a remainder? The first smallest is 2. So when I use a 2, I will simply come and say, I write my 2 here. Then I ask myself, how many 2's can I get from 12? When I divide 12 by 2, what do I get? The answer button is 6. It brings me to the second step. Then I ask myself, in the second step I'm having 6. Can I still use 2? Yes, I can use the 2 still. Then I ask myself, when I divide 6 by 2, what happens? Each one takes 3, alright? Then when you check this third step, which prime number can divide 3? I'm just going to use 3, it's solved. So I write a 3. 3 divided by 3, the last answer is 1. When you reach 1 as the last step, it means that you prime factorize the 12 completely. So I will say 12 is equivalent to, mention the numbers that you've used to prime factorize 12. So I'm having the 2 for the first time, comma. The second 2, it gives me 2 for the second time, or 2 subscript 2. Then 3 is appearing for the first time, right? So having gotten the sets of the prime factors, I can now go back to the question. They told me, show the prime factors of 18 and 12 on a Venn diagram. Having gotten the prime factors, I can now go ahead and I draw up the Venn diagrams. So the Venn diagrams, we can use the circles, circular representation. Have the circles, 2 of them, like this. The first one, call it a set of factors of 18. Then the second one, call it a set of factors of 12. Right? So having drawn up the Venn diagram, in the first place I must sort out the common factors. When you look at 18, I'm having 2 to subscript 1, 3 to subscript 1, and 3 to subscript 2. Then, when you go to 12, I'm having the factors as 2 to subscript 1, 2 to subscript 2, and 3 to subscript 1. So we can identify the subscripts in common. When I look at the 18, the set of 18, it has 2 for the first time. Then 12 has 2 for the first time. So we shall say, we can mark this one as being common. Then we shall represent it in the middle part of the Venn diagram because they are common members. So 2 for the first time is represented. Then we go still and check. 3 for the first time, or 3 subscript 1 is seen in the set for 18. It is also seen in the set for 12. So it also becomes a common member. Put it under the intersection region. So after representing the common members, we can go back and ask, under the set of 18, which member is not represented? It is only one member, which is 3 to subscript 2. Then when you go to the set of the prime factors of 12, which members are not represented? It's only 2 for the second time, or 2 to subscript 2. So I'll write my 2 to subscript 2 under the factors of 12 only. So by representing these members, or the prime factors of the two numbers, I've completely answered the question according to what they wanted. Okay? Yes. We can have the second question. and probably could be I may not complete it, but let me give this second question here. The second question says, represent the prime factors of 24 and 20 on a Venn diagram. So the question is almost the same as what we've done in the first question, but what has changed are the numbers. So what are we supposed to do before we draw the Venn diagram? We shall go get the prime factors of these two numbers. In the first place, getting the prime factors of 24, just draw up a ladder. Represent our number 24, which is here. Then you go back to the set of the prime numbers. Which smallest prime number can divide 24 without a remainder? It is a 2. Then you ask yourself, when you divide 24 by 2, how many 2's do you get? The answer is 12, right? In the second step, I'm having number 12. I can still divide it using the 2. So we shall put our 2 here. Then you ask yourself, how many 2's are in 12? The answer is 6. The third step has a 6. Which prime number can still divide 6 without a remainder? I can continue using my 2. Then we shall say 6 divided by 2, the answer gotten is 3. So when you reach this fourth step, the number I'm having is 3. Out of the prime numbers, which one can divide 3 without a remainder? It is 3, it's solved. When I divide 3 by 3, the answer I get is 1. So from there, when I reach the last step giving me the final answer as 1, it means I've completely prime factorized 24. So for that case, what am I supposed to do? I will write the prime factors of 24 as 24 is equivalent to 2. I'm seeing it 2 for the first time, 2 for the second time, 2 for the third time. So I'm going to write it as 2 for the first time with a comma, 2 for the second time, then 2 for the third time, then 3 is there for just one time, 3 for one time. So I've gotten the prime factors of 24, right? Since there are two numbers, be organized, go the other side. Get the prime factors of 20, just draw up a column to form up a ladder. Represent our number 20 using the possible prime numbers. Which one should I use? 20 is an even number, I use a 2. So we shall say 20 divided by 2, each one gets a 10. Then we can continue. Since 10 is also an even number, I can continue using 2. When I divide 10 by 2, the answer gotten is 5. So on the third step, I'm having 5. Which prime number can divide 5 without a remainder? It's only 5, it's solved. So I will divide it by 5. 5 divided by 5, the final answer is 1. Therefore, since I've reached the last step as 1, I can say 20 is equivalent to 2. 2 is appearing for the first time, comma, 2 is appearing for the second time, then 5 is there for just one time, so it is written as 5 to subscript 1. So after getting those prime factors, you can now go ahead and draw up the Venn diagram just like we did it in the first example. But because of time, I'm not going to complete it. You will find time and complete it yourselves. Thank you so much for being part of this lesson. Teacher Robert from Light Academy. At the end of the lesson, you're supposed to answer the questions that have been provided in the activity below. I think you'll be in position to answer them well and enjoy them. Stay home, stay safe. Teacher Robert, Light Academy, Nursery and Primary School.